Hi, welcome to live class. So we discussed in last class. We discussed in the last class. See, so this is the north, south, east, west. So if an aeroplane walks towards north, that is equal to 400 meter. Then towards west, 300 meter. Then what happens after this? It goes up like this. So that means this is the initial position, this is the final position. Last class problem I am explaining here. So the distance between initial and final positions. So see what happens here. For example, this is north, then west. This is north and west. Then perpendicular to this, like this. Otherwise, like this. North west goes up an aeroplane. See what happens, like this. So this is the initial position, this will be the final position. So we have to calculate the displacement between initial and top of this point. This is final. I think you understand this one. This is initial position, this is the top of, this is the final position. So if we draw a line here to here, here to here also we will get one line. So we will get one triangle here. This is also one triangle. So from first triangle we are calculating here 500 meter. So this is 500 meter, this height is 200 meter, then this will become 1300 meter. So here it is perpendicular to this one. So by using Pythagoras law, that is hypotenuse square equal to opposite side square plus adjacent side square. Opposite side square plus adjacent side square. So here 500 meter plus 200 square, 2500 plus 144,000. So you will get 169. So that is equal to h square. H equal to hypotenuse equal to, so under root this one will get 1300 meter. So simple. So here what is the concept here? Displacement is nothing but between initial and final positions, the distance, the shortest distance between initial and final position. This is the initial position. It went up and it went to north and goes to up west, then goes to upward side. So this is initial, this is the final. So for this line, if you want to calculate this line, we have to know this one and this one. So from this triangle, for this one, this from this triangle, this is 400 meter, this is 300 meter, this will become 500 meter. Then we have, this is one more triangle, we have two triangles are here. In two triangles we have, one side is 200 meter, one more side is 500 meter. So these two are perpendicular to each other, then the hypotenuse will be 1300 meter. So the displacement from initial position is 1300 meter. So this is how do we calculate displacement. So I will give one more problem to you. a car a car moving with, write this problem, a car moving with a uniform velocity, with a uniform velocity of 44 meter per second. A car moving with a uniform velocity of 44 meter per second overtakes another car. Here car A, this is car A, this is car, another car B. A car moving with a uniform velocity 44 meters overtakes another car B, which is just moving from rest with an acceleration of 2 meter per second square after how much time do they meet again? Write the question first. So what is the question here? A car A moving with a uniform velocity of 44 meter per second overtakes another car B, which is just moving from rest with an acceleration of 2 meter per second square. After how much time do they meet again? So this is the question. So is it visible to you? Message me yes or no. Is it visible? Yes. Now a car A moving with a uniform velocity of 44 meter per second 44 meter per second overtakes another car B, which is just moving from rest with an acceleration 2 meter per second square. After how much time do they meet again? This is the question. See, for solution, car A, for example, this is car A moving with 44 meter per second is moving, overtakes another car B. This is car A, car B, which is just moving from the rest. For this car, initial velocity is 0. With an acceleration, it is moving A equal to 2 meter per second square. See, car B is moving with initial velocity 0 and moving with 2 meter per second acceleration. Car A is moving with uniform velocity. So this will become, this is uniform velocity. So we have here two cars. One is car A, one is car B. Car B is moving with 2 meter per second acceleration. It is started from rest. So car B started, it is moving with uniform acceleration. For uniform velocity, it is moving with uniform velocity, it is moving with uniform velocity. A equal to, acceleration of the car is A equal to 0. So here the question is, a car is moving with uniform velocity 44 meter per second, overtakes another car B which is just moving from rest with an acceleration 2 meter per second square. After how much time do they meet again? So it is moving. For example, here the point C, car B reached here, then car A reached here. At this point, the two cars meet again. The two cars meet here. Got start and here they met. So after how much time? For example, take t time. Take t time. In t time only it has to travel here to here. It has to travel here to here. So how much distance? For example, take x. Here also, here up to here it is x. Then remaining some displacement. For example, this is h. So the question, did you understand first? Come on. Car A is moving with uniform velocity, that is 44 meter per second. See, any car or any body, any particle moving with uniform velocity, the acceleration of the car or body is 0. Acceleration of car or body, that is equal to 0. Car B is moving with uniform acceleration. This is moving with uniform velocity. This is moving with uniform acceleration. Initial velocity is 0. So we have the questions. We have the formulas. So here, for example, in t time it traveled. So displacement covered by this car, that is x equal to ut plus of at square. Ut plus of at square. Here initial velocity is 0. So we can say here this will become 0. Half into 2 into t square. So x equal to t square. X equal to t square, distance or displacement covered by this car B. Then in t time only, the car B travel up to here to the C point. In the same time, car A also travel up to here. Then only two cars will meet. Then only the two cars will meet. So we are writing here, is not visible. Here, so we have car B, we have car A. For car B, see, it has to travel x displacement to reach C. Okay, so s equal to, we have ut plus of at square. So the displacement we are here, let the displacement be here x. So u is, it started with the initial velocity 0 plus half. It is moving with constant acceleration, that is equal to 2 into t time it traveled here. So x equal to, we got t square. This is equation number 1. So the displacement covered by the car in t seconds, x equal to t square. For car A, we have to check it. For car A, u equal to 44 meter per second, A equal to 0. In the same time, the car A also has to reach here. Then only the two cars will meet. So here, this is x. Up to here it is x only, x plus h. It has to travel x plus h. ut plus half at square. Here u is 44. A is 0. A is, acceleration is, for car A is 0. So this will become 0, x plus h. So x plus h equal to 44t. This is the second equation. Is it or not? Yes. So what happens here? In t time car B travels x displacement, car A has to travel this x plus h, some more distance. So here from these two equations we can substitute. So this is the h behind the car. So is it started at the same time? What is the question? See, the question is here car A and car B. See, this is not behind car B is not behind the car B, because car A and car B started here only. First it overtakes, then we have to check where they will meet again. Okay, for that one we don't consider h here. So here x equal to t square, 44 into t. From these two equations t gets cancelled, t equal to 44 seconds. So the answer is 44 seconds. See, I will explain one more time clearly to you. See, in the question he has given like this: car A, this one, then car B, this one. Car A and car B. For car A, it is moving with u equal to 44 meter per second. It is moving with uniform velocity. For uniform velocity body, acceleration is 0. For car B, it starts from rest and it is moving with acceleration 2 meter per second square. So this is the information. First, somewhere car A and car B started and overtakes here. So car A overtakes car B. Car B is moving from here to from where it has started somewhere. Car B already started somewhere. It is moving. After some time, car A came and overtakes car B. Car A overtakes car B. Car B started with initial velocity 0. It is moving with uniform acceleration. Car A overtakes. It is that car A which the car A is overtakes car B. The car A is moving with 44 meter per second. It has acceleration 0. So the question is, after overtakes, see here first they meet, first they meet, then after how much time? After how much time they meet again? This is the question. They meet again. So it has to travel same distance x. Car B also has to travel same distance in time t. So car A has to travel x displacement to reach C. Car B also has to travel x displacement to reach C. Then only both cars will meet again in t time. So for car B, what is the information we have? It started from rest. It is moving with constant acceleration. So E equal 0, A equal to x equal to t square. This is equation 1. So for car A, x equal to ut plus of at square. Here it is moving with constant uniform velocity, that is 44 into 2 plus 0, x equal to 44 into t. From these two equations we got 44 seconds. We got t equal to of 44 seconds. That means, see, car A overtakes car B. After 44 seconds, car A and car B meet again. They will meet again. Car A, then car A and car B meet again. It will take 44 seconds. So this is the answer. Just copy it. Have you understand this is the problem? Have you understand? Yes or no? Come on, say. Is it okay? Car B is moving. After some time, car A came and overtakes car B. Once they meet here, if they want to meet again, how much time take? That is the question. After what time it will meet again? Next problem. Next problem, right? A particle, a particle moves moves along side of square of length square of length L, starting from A and reaches the opposite corner C by traveling from A to B and from B to C if the time taken is T, the average velocity of the particle is. So this is the question. So here a particle moves along the side of a square of length L starting from A and reaches opposite corner C by traveling from A to B and from B to C if the time taken is T and average velocity of the particle is. So this is the question. How the question is? How the question? So this is the square. This is square. Particle moves along the side of the square of length L. So the side of the square L L L. Here the particle starting from A and reaches opposite corner C. So this is D, C, D. It reaches opposite corner C by traveling from A to B. So it travel A to B and B to C. A to B and B to C. So here just read the question. A particle moves along the side of a square of length L starting from A and reaches the opposite corner C by traveling from A to B. That means the particle started here, it goes A to B, then reaches C. So the particle finally reaches opposite corner of A. Opposite corner of A, that is A to C. Okay. See, it reaches opposite corner by traveling A to B, then B to C. So the side of square is L. If the time taken is T, average velocity equal to total displacement by total time. So you have to first you do this one. First you just do this and solve the problem. First read the question. Find out average velocity, total displacement by total time, average velocity of the particle. You just find it. Come on, do it. Here a particle started from A and it traveled along A to B, then travel along B to C, finally reached C. So this is initial position, this is initial position, this is final position of that particle. So what we require here, displacement of the particle. So this is the displacement, the shortest distance between initial and final positions. Initial and final positions. So this is L, this is L. What about this one? So this is equal to nothing but 2 root to L. So how much time it has taken to reach this one? T. So here total displacement nothing but root to L. Total time taken is small t. So this is average velocity equal to root to L by t. This is simple, root to L by t. Just copy it. I will give one more problem. Okay, right. So one more problem. Here problem next, a bus starts starts to move. A bus starts to move with an acceleration with an acceleration of 1 meter per second square. A man a man who is 48 meters behind the bus runs with constant velocity of 10 meter per second to catch it. In how much time he will catch the bus? So this is the question. So what is the question here? A man starts to move with an acceleration 1 meter per second square. A man starts to move with an acceleration that is equal to 1 meter per second square. So here the bus here the bus starts to move with an acceleration a equal to 1 meter per second square. A man who is behind 48 meter, so behind 48 meter behind the bus runs with constant velocity is the man to catch it. This is the bus. Here we have two objects, one is bus, one more is man. The man moving with the bus starts with constant acceleration. It is moving with constant acceleration, that is a equal to 1 meter per second square. A man who is 48 meter behind the bus runs with constant velocity, that is equal to 10 meter per second to catch it. So he is running to catch the bus. So already he is behind the bus. He is behind the bus 48 meter. So this is the situation. Bus is here. The man is here. He is behind the bus 48 meter. He is moving runs with 10 meter per second with uniform velocity. For any uniform velocity, the acceleration of the man is a equal to 0. This person is moving and he has to catch the bus. Okay, here, so for time t, in time t, the bus will goes here, point C. The man has to catch the bus. He has to travel up to here. Then only he will enter into the bus. he will enter into the bus. This is the situation. What is the situation here? The bus is moving with an acceleration a equal 1 meter per second. It is moving and moving. The man is here behind the bus. How much distance he was there? 48 meter behind the bus. The man is also moving with uniform velocity 10 meter per second to catch the bus. So after it started, the bus is moving, the man is running. After time t, the bus will go to see here. It has to travel x displacement. It has to travel x displacement. Some displacement in time t, the bus will move and reach point C. In that time only the man has to move that distance. So here the distance is x, behind is 48 meter plus x. 48 meter, then the bus travel distance. So 48 plus x meter distance he has to travel to catch the bus. So for bus, so situation here for bus a equal to 1 meter per second square, then u equal to 0, t equal to t. What about displacement? That is equal to ut plus half at square, half into 1 into t square. So x equal to t square by 2. So the bus travel distance x equal to t square by 2. Here man is there. For man, he is traveling with 10 meter per second. Acceleration equal to 0. So he has to travel x plus 48. So we have the formula s equal to ut plus of at square. Okay, here s equal to u equal to 10 into t plus half a equal to 0. So displacement he has to cover 48 plus x, that is equal to 10t. This is equation 2. Equation 1 is equal to t square by 2. Equation 2, 48 plus x equal to 48 plus x equal to 10t. From these two equations I will solve here. X equal to t square by 2, this is the equation 1. 48 plus x equal to 10t, equation 2. So just substitute equation 1 in equation 2. 48 plus t square by 2 equal to 10t. T square equal to 96 plus 10t minus 10t equal to 0. So t square equal to minus 12. So how can we split here? 20t. So 96, 12, 8 ja. So t square minus 12t minus 8t plus 96 equal to 0. T of t minus 12 minus 8 minus 12 equal to 0. T minus 12 equal to 0. T minus 8 equal to 0. Is it visible? Okay. So we can say t equal to 12 seconds. T equal to 8 seconds. So 12 seconds or 8 seconds, then the man catch the bus. The man will catch the bus. So have you understand the question first? If you understand, message me yes. If you not understand, message me no. I will explain one more time here. No, okay. See, this is the bus. This is the bus. Here is the man. Man is behind the bus 48 meter. Already he is behind. Behind means venuka. The bus is moving with a uniform acceleration 1 meter per second square. So which started from rest. Rest to start a equal to 1 meter per second square moving to the moves in bus. The man has to catch the bus. The man has to catch the bus. Bus and catch చేయాలనుకుంటున్నాను. So he is running with 10 meter per second. with uniform velocity. Uniform velocity he has to catch the bus. Is running with uniform velocity. So for uniform moving any body, the body's acceleration is equal to 0. The body's acceleration is equal to 0. So we have two cases here. For bus, what is happening? The bus is moving with 1 meter per second square. Its initial velocity is 0. So after t time, in t time, so bus started here. The bus went to here. The man has to move here. Then only he catch the bus. He has to enter the bus. So he has to run this distance. The bus is moved this distance. So if he has to catch the bus, he has to travel 48 meter, already is behind the bus. 48 meter plus the bus travel distance x. 48 plus x distance, if you cover in t time, the bus will cover in t time x displacement. So here a equal 1 meter per second, so the bus is moving. It started with initial velocity 0, time t equal t. So s equal to ut plus half t square, already we have the formula, that is second equation, kinematic equations. So x equal to u is 0, so half a t square, t square by 2, x equal to t square by 2, this is equation 1. For man, he is moving with uniform velocity, that is equal to 10 meter per second. He has the any body or any particle, anything which is moving with uniform acceleration, we have to take acceleration equal to 0. Acceleration equal to, why we are taking acceleration equal to 0? V a equal to what? A equal to v minus u by t. Initial velocity equal to final velocity, then v minus u equal to 0. So acceleration is 0 here. So s equal to ut plus half a t square. Here u is 0, then half a t square. Half it acceleration is 0. So 10, just this term will goes to 0. So u into u is 10, 10 into t. So 10 is the band has to cover how much displacement to reach the bus, to catch the bus? 48 plus x. So this is the second equation. This is the first equation. So first equation and second equation. If you know some solving of that means equation, that is a squared equation. That see here 48 x equal to t square by 2, I substituted here 48 plus t square by 2 equal to 10t. So I solve for t equal to. So I got here x equal to t square by 2, 2 into 48, 96. 2 10 are 20, minus 20 t square plus 96 minus 20. This is a quadratic equation. So I solve for t. If you know mathematics, little bit mathematics, you can get t equal to either 12 or 8 seconds. So in 12 seconds or 8 seconds, the man can catch the bus. The man can catch a bus in 12 seconds or 8 seconds. Oh, this is a solution. You just copy it and understand the problem. If you are not able to understand, I will explain tomorrow also. First you just copy it. Is it okay? Okay. just practice the problem. Not visible. So this part is no, you are not visible. Which part? This one. So I will rub here. So I will solve here. X equal to t square by 2. This is equation 1. 48 plus x equal to 20. This is equation 2. Okay. Okay, now I substituting here 48 plus t square by 2 equal to 10t. So 96 t square equal to 20t. 96 plus t square minus 20t equal to 0. So if we go here, t square minus 20t plus 96 equal to 0. This 22 we can write is a quadratic equation in terms of t. So we can solve for t. Minus 20t we can write minus 20 minus 80 plus 96 equal to 0. T of t minus 12, take common minus 8 minus 12 equals 0. So t minus 12 into t minus 8 equals 0. T minus 12 equals 0. T minus 8 equals 0. T equal to 12 seconds. T equal to 8 seconds. So is it visible? I think now. Yes or no? Okay. Okay. We just copy it. I will explain tomorrow one more problem. So somewhat MSET problems these are. So by looking, if you cannot understand that much easily, but you try it and practice the problems. I explained today only 3 problems to you. You just practice it and ask any doubt tomorrow. Okay. In first question, car A, car B. Car A overtakes car B. Then they have to meet. At what time they will meet? That is the question. In one more question, a man is behind the bus. The bus is moving. A man is moving to catch the bus. So where will they meet? Otherwise, where the man will catch the bus? That is the question. In between, I given one more average displacement. Average displacement is nothing but total displacement by total time. Okay, thank you. Bye.